All right, I'm going to go over this practice test. Hopefully it's going to take me less than 10 minutes. While I'm going over it, I'm going to ask you some questions, but as well, you might want to stop it and take some notes on the back of your notebook check, which you should also have. There should be a place to write cheat sheet stuff. I don't know why the title didn't come out, but it should say cheat sheet on the back, because you're going to write down things like, I think I'm going to forget this stuff. This might focus a little bit off. Anyway, to start with, I think I'm just going to do the top part here, and you can do the bottom part on your own. In fact, I'm going to do the second part. It's a little harder because they're both the same kind of problems, and all of them we're looking for slope, distance, midpoint. I tell you, you need to use the formulas for getting full credit, which means you might want to write the formulas on your cheat sheet. So my slope formula is y2 minus y1 over x2 minus x1, just as a reminder. So if I take these in this, I'm going to say this is my y2, so negative 7 minus 2, and that's over the 5 minus negative 3. And so that's going to be a negative 9. That's like a 5 plus a 3. All right, I think this is negative 9/5. We'll know in a second when I check it over here. But right now, that is my slope. That's me using my formula. My midpoint formula. This is where I average the x's, so x1 plus x2 all over 2, and then the other thing is y1 plus y2, if I can write it correctly. So I'm just going to add these together. So negative 3 plus 5 are my x values divided by 2, and then my other two values are a 2 and a negative 7 over 2, and so that's a positive 2 over 2, or 1. And the negative 7 plus a 2 is a negative 5, so negative 5 over 2 is negative 2.5. So once again, in a second when I check it down here, hopefully that'll match up. And then finally, the distance formula is the square root of my x's subtracted plus my y's subtracted. And both those squared and square root, because basically it's Pythagorean theorem, but this part is just figuring out how long this thing is. So when I subtract my x's, once again, I'm going to keep it in the same order. I'm going to do 5 minus, no, not 2, minus negative 3, same as it is right there. It's a little hard to read. And then same as I did up there, negative 7 minus 2. Either this is all going to be right or it's all going to be wrong, because I'm copying down my formula from above. Okay, this is going to be the square root of, I did do this wrong up here. I don't know why I wrote 5 there. 5 minus negative 3 is 8. I'll probably make sure you check that in a second. Okay, so once again, that's an 8 squared, and this is a negative 9 squared, which we know is going to come out positive when we square it. So this is the square root of 64 plus 81, square root, I've got to do this in my head. That's 5 and 145, I think. I'm doing this in my head. And then whatever the square root of that is. So it's 12 point something. I know, 12 point, if I got my calculator out, something. But square root of 25 is what it is. Okay, let's verify this. So if I actually graph these, negative 3, 2 is right there. 5, negative 7 is way down here. So if I connect this whole thing, it is got a slope of down 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. You can't see what I'm doing. 1, 2, 3, 4, 5, 6, 7, 8. Negative 9 over 8 was correct. We're good there. 1 over negative 2.5. 1, negative 2.5, that looks about like it's in the right place. So I'm going to guess that was right. And then finally, there's no real way for me to check this other than I do. It is 8 squared. So if I just double check my math, that is 64. That's 81, 140. Yeah, pretty sure that's right. It's long-ish. It's hard for me to tell. It's exactly 12. But that's me kind of double checking myself. Okay, so that took me 4 minutes. The other one will probably take me another 4 minutes, so that's 8 minutes. But I'm not going to do that because it's the same thing. The only different thing is I'll tell you up here, your slope is positive. I made it so 0, 2 is, I'll go ahead and graph it for you. 0, 2 is here, and 6 5 is there. So we know we're going to have positive slope, and we can figure out how long this is with our little right triangle, and we can also find the midpoint is somewhere in there. But I'm not going to do the work for that one. Okay, this one, I hope I got 25 and 110 on yours. If I wrote something different, the process will be the same, but your answer will be slightly different. Okay, so fill in all the missing angles, then transfer the answers for the specific angles in the space below. I'm asking for some specific ones down here. All right, so that's 110. That's got to be 70. My triangle has to add up to 180. So 70 and 90 and 20 is 180. That's how I got that. Let's see. This is a right angle, which means this also has to be a right angle because they're alternate interior. So that's also 90. So if this is 90, these three have to add up to 180. So this is 70. This is not the only way to find that, but that's the way I saw it. Here I have vertical angles. So that's 70. It's also, these are corresponding angles right here and right here. So that's got to be 70, which I'm just going to jump down because this is a question down here. It asks what's a corresponding pair. That's 70 and that's 70, as well as this 110 and this 110 are what are called corresponding pairs. Okay. So I'm going to go ahead and write that down right now. ACB, angle ACB is a corresponding pair, ACB, with CFE. CFE, that's taken care of. Okay, let's see, what have we not done? Oh, once again, triangle's got to add up to 180. 25 and 70 is 95, so this thing is 85, even though it looks a little bit like a right angle. I'm pretty sure if that doesn't add up to 180, I'm doing this fast, those have to add up to 180. This is going to be 90. What angles haven't I filled in? Oh, this one, vertical angles, 110, and that's got to be 70, and I think I got them all. All right, so let's transfer ABC. ABC, that's 25. Okay, CAB, CAB, that's 85. Notice how I'm doing that. I'm just counting the letters. It's the middle letter, but I've got to, so CFE, CFE, that's 70. ECF, ECF is 20, even though it doesn't look like it's 20. CFG, CFG is 110. And DCF, DCF is 70. All right, hopefully I did all that right. What's left down here? Oh, vertical pair. Like the 70 and the 70 is a vertical pair. The 110 and the 110 is a vertical pair. So I'm going to use those two. I'm going to do CFE. And then the other side of it is GFH. GFH. A linear pair. Linear pair is like the 110 and the 70 and the 110, the 110 and the 70 there, the 110 and the 70 there. Those are all linear pairs. So I'm going to grab those two. So let's say GFH and HFE. All right, I already took care of the corresponding. It was the ACB, which is that 70, and the. Now notice it's not just because they're 70; it's where they are. So I got parallel lines. Upper left is 70. Upper right and upper right is 110. Those are corresponding. Lower right and lower right is 70. That 20 doesn't correspond to anything because there's anyway. So let's see what's left. Draw the following. Line A, ray AB. So I'm going to draw a ray from A to B, and then CD, and they're supposed to be parallel. So I'm going to draw something up here, CD, and then to make them parallel, I'm going to mark them as parallel. Okay. Oh, I guess probably shouldn't have this little bit on the A. It's still a ray, but the arrow is going in this direction because that's what the ray does. Okay, we got segment EF. So E to F. And GH are perpendicular. It doesn't say where they intersect. So I'm just going to make them intersect right here. The G and the H can be anywhere. Just have to be on that line somewhere. So the G and the H. There we go. And I should put a little right angle in there so that you can tell by looking at, I'm describing the perpendicular. That's our perpendicular symbol. That's our parallel symbol. XYZ is an acute angle, so that would just be, I just need to make it look small, make it look less than 90. The Y is the center, and then the X and the Z can be on either part. And because this is not described, I can either have arrows on that or not. That kind of doesn't matter. It's not clear. What's left? Isosceles triangle, ABC, with congruent legs AB and BC. So I need to make two of the legs look like they're the same and mark them. And then so the B is the middle angle there, and I got A and the C here. Right triangle DEF with hypotenuse EF. So I got a right triangle, hypotenuse EF, or it could have been FE, doesn't matter. And then that's got to have to be the D. And then finally a square with markings, which you've done a ton. Looks like this. I got to have 4 right angles. Now it's just a rectangle, but if I say all the sides are the same, now you know it's a square. Okay, 11 minutes. Now, granted, for you to do this, if you knew what you were doing, you could probably do it almost as fast as me, and then another few minutes to do that. So this is a test. It's supposed to be longer. So to take 30 minutes on a test like this would not be unusual, and that's probably about how long I'll give you for it. That's it. Thanks.